Okay, so in this video we're going to look at covalent bonds, but before we look at covalent bonds I want to do a recap on the periodic table and ionic bonding because it's important and it's related. Now, the first thing I'm going to do again is to just highlight where the metals and the non-metals are. So again, we're making a stepped line down aluminium all the way to polonium, and I suggest you guys do this for your real exam with the periodic table that you're going to be given. I suggest that you make this line, and anything on the right hand side of this line, so all of these elements here, every single one of them is a non-metal, including hydrogen. Okay, hydrogen is the odd one out. We've already spoken about hydrogen in I think the first or the second video. So, and obviously hydrogen gas is a non-metal. Okay, and now everything to the left of the stepped line, everything on this side here, every single element, including those in the stepped line, right, all of these are metals. They've got metals and non-metals. Now with ionic bonding, as we said, it's the bond between a metal and a non-metal so these join together, react together to form an ionic bond. What we also should know is that the metal donates the electrons, and in doing so it becomes more positive, so it becomes positively charged, and because it becomes positively charged, we call these cations, because a cation is a positively charged ion. And remember, pussycat. Next we've got the non-metals. So with the non-metals accept the electrons to make a full outer shell, and because they're accepting electrons they become negatively charged, which means, and a negatively charged ion is called an anion. Okay, so it's called an anion. So that's a recap of ionic bonding. Now what we're going to look at is covalent bonding. Covalent bonding is to do with this side only, the non-metals. So covalent bonding, let's change that color because it's a bit rubbish. So covalent bonding is the joining, is a bond that occurs between two or more non-metals only. Non-metals. Okay, so that's everything on this side of the stepped line. So anything on the right hand side of the stepped line, including hydrogen as well. So these are the things that are going to react to form covalent bonds. Now, you need to be aware of these four that I've written on the side. Okay, so these four here, you need to be aware of how to draw a diagram, a cross and dotted diagram, to show what happens to the electrons during covalent bonding. So I'm just going to tell you that methane here has a molecular formula of CH4. Okay, so that's C1, because we looked at methane in C1. Hydrogen chloride has the formula HCl. Water has the formula H2O, and hydrogen has the formula H2. Okay, so now we're going to make a cross and dot diagram for each one of these. I'm going to start with hydrogen, and hydrogen, as we know, is in period 1, and it looks like this. So top number is 1, bottom number is 1. We're going to use the bottom number because that's the number of electrons. Hydrogen has 1 electron, so I'm going to write a H here, and I'm going to give this one a cross. So here's my cross representing my electron. Hydrogen has 1 electron only, and I'm going to make this hydrogen here, I'm going to give it an electron shell, and I'm going to represent its electron with a dot. There's my dot. So when we join these two together, we're going to make one hydrogen here with our cross. Right, so there's my cross, and the other hydrogen here, and they're going to share the electrons, and so here is my dot. I need to change the color for my dot because it's not really showing up very well. So here's my dot, and that's what covalent bonding is. Covalent bonding is the sharing of electrons between non-metals to form a complete outer shell. So a complete outer shell. If you think about it, if you look at hydrogen, this is the inner shell and it doesn't have any more shells, and the maximum you can have in the inner shell is 2 electrons. So you've got one from the cross, one from the dot, so it's got a full outer shell. Now let's look at let's do HCl next. Okay, so I'm just going to get rid of all of that, So we're going to do HCl, so hydrogen chloride. Now hydrogen, again, we know that it's got 1 electron in its outer shell, so I'm going to draw that and I'm going to represent this. There's the cross, and Cl. Now Cl, so if this is period 1, this is period 2 is across there, this is period 3, so Cl is in period 3, so I know it's going to have 3 electron shells. So here's 1, 2, 3, right? And if we look at the number for Cl, so Cl has 35.5 at the top and 17 at the bottom, so it's going to have 17 electrons in total. So I'm going to change the color for my dot, so I'm going to make this one dot. So that's 1, 2, I know this is going to have 8 because I need to move on to the next ring. So this has got 8, 2, 4, 6, 7, 8, and I know that it's in group 7, so it's going to have 7 in the outer shell. So I'm going to draw 1, 2, 3, 4, 5, 6, and 7. Now can you see this electron here has no friend? So covalent bonding is the sharing of electrons to make a full outer shell. So when we join these two together, it'll look something like this. So we've got our H here, cross. Oh, let's do that again. That bloody, whatever you call it, moped, whatever it is outside distracted me. So we've got our H here with our cross, and we're gonna have the dot from the Cl here, and I'm going to ignore all of the inside rings now, and I'm just going to focus on the outside rings. And this is a typical question that they could ask you. It's like, why is it okay to ignore the inside rings? And the reason is because it's the outermost electrons where the sharing is happening and not the innermost electrons, so you can forget about the inside rings. So I've ignored these rings here, these ones on the inside, so that we can see what's happening on the outside. So I've got 1, 2 there. This one is now no longer alone. It now has this friend with it, and I've got the remaining dots there. So I've got 2. Oh, let's change the color. I've got 2 here, right? And I'm gonna have 8 outs in the total, aren't I? So can you see that chlorine, by sharing, it's got 1, 2, 3, 4, 5, 6, 7, 8, and hydrogen has 1, 2. So they both have full outer shells. Now guys, you must know that you can ignore the inner shell for covalent bonding because the bonding happens on the outer shells. Okay, the sharing of electrons happen on the outer shell, so you can ignore the inner shells. I'm not just cheating, I'm not being lazy. You need to know that. Okay, so that's HCl done. Let's have a look at H2O. So this is water, H2 and O. So what this is telling you is that we're going to need 2 hydrogens and 1 oxygen. So let's draw the oxygen first. Okay, so I'm going to draw the oxygen. I'm just going to... Okay, so I know, so let's look at what period oxygen is in. It's not in period 1. oxygen is in period 2. There it is. Okay, so I'm going to highlight that. The code for oxygen is 16 at the top, 8 at the bottom. We're interested in the number of electrons, so it's going to have 8 electrons in total. But because it's in period 2, it's going to have 2 rings, 2 electron shells. And it's in period 6, group 6. So that means it's going to have 6 electrons in its outer shell. So period 2, so I know I'm going to write oxygen. And with oxygen, guys, I suggest that you write oxygen because otherwise it will confuse you. I'm going to get rid of these. Let me get rid of these lines now. It's too much. It's too messy. So H2O, oxygen is 16 and 8. So let me draw oxygen. I'm going to write oxygen. That'll do. And it's in period 2, so I know I need to draw 2 electron shells. Let's draw the crosses in a different color. So I've got 1, 2, right, and it needs 8 in total. Remember, 8 electrons. So, and I know that. Okay, so 2, 3, 4, 5, 6, 7, and 8. So can you see there's 2 electrons that are alone? Well, that's convenient because I need 2 hydrogens. So here's my hydrogen number 1 that I'm going to draw. And as we know, hydrogen has only 1 electron. So I need to represent this with dots. So my hydrogens are going to have dots. Here's my first hydrogen. Here is my second hydrogen. Okay, so here's my second hydrogen. Isn't that convenient, guys? 2 free electrons and we need 2 hydrogens. So when we combine this, so H2 plus the O, we're going to end up with H2O. I'm just going to get rid of the periodic table now. So if we've got the H2 and we're going to combine all of this together, so I'm going to combine all of this together, this is how it'll end up looking. So again, I can ignore the inside ring for oxygen because everything happens on the outside ring. And so I'm ignoring this ring, guys, just to highlight it to you. I'm ignoring that. And so what I've got is I've got 1, let's change the color, 2, 3, 4, and I've got these 2 that are lonely. Now of course what's going to happen is you're going to have the hydrogen number 1 is going to come and pair up with this oxygen and share its electrons. So here's my first hydrogen. Let's put a dot in there, change the color though. So here's my, can you see it's sharing with that X? Let me just highlight that X and it's on top. So that's sharing, and finally I'm going to have another hydrogen here. So the other hydrogen is going to be sharing with this bad boy here. And we're going to need a dot from this hydrogen. Bad choice of color. So here's my dot and here's my cross. And now can you see, look at the oxygen. There's 2, 4, 6, 8 for oxygen. That's a full outer shell. And for hydrogen, hydrogen has 2 and this hydrogen has 2. So they both have full outer shells. Okay, so we've done hydrogen chloride, we've done water, we've done hydrogen. Now we're going to do methane last. Okay, again, there's nothing difficult about this. I'm just going to scratch all of this off, get rid of all of this. So let's do methane. Okay, so again, methane is to do with CH4. So what we're going to say is we need the carbon. What group is, what period is carbon in? Let's get rid of the opacity. Okay, so carbon is in period. It's not in period 1. It's in period 2. So I know carbon's gonna have 2 rings. So I'm gonna do carbon with 2 rings. 1, 2. Right. Carbon. This is the code for carbon. It's 12 and 6. So it's gonna have 6 electrons in total, but 4 in its outer ring. So that means 1. Let's change the color. Let's make a good choice. So I've got 1, 2. And I need 6 in total. So 1, 2, 3, 4, 5, 6. So remember, methane is CH4. Now there are 4 lonely electrons. Isn't that convenient? And we need 4 hydrogens. So hydrogen, of course, has 1 electron in its outer shell. So here's the first hydrogen, here's the second hydrogen, here's our third hydrogen, and here's our fourth hydrogen. Let me just mix the colors up for the electrons. So here are my 4 hydrogens, 1, 2, 3, 4, and they're going to combine with the carbon. Now again guys, remember I can ignore this inner ring because this is not where the reaction happens. The reaction is happening on the outer ring. So what I can do, I can get rid of my periodic table now. So what I'm going to do is I'm going to have my carbon with its outer electron shell. How many electrons in the outer shell of carbon? That's 4. 1, 2, 3, 4. They are all 4 of them are lonely, so they're gonna share the electrons with hydrogen. So that's the electron from hydrogen. That's another electron from hydrogen. That's an electron from hydrogen. That's an electron from hydrogen. Dots and crosses, guys and girls. So here's my hydrogen. Here's my hydrogen. Here's my hydrogen. Here's my hydrogen. And can you see that they are all sharing? So this hydrogen will have 2 electrons. This hydrogen will have a full outer shell. This will have a full outer shell. This will have a full outer shell. And if you look at carbon, it's got 2, 4, 6, 8 electrons. So both carbon and hydrogen have a full outer shell. And that is the point, ladies and gentlemen, of covalent bonding. It's between non-metals. Oops, that's non-metal. Non-metals, and they share electrons. Why? So that they have a full outer shell. I hope this helps. Okay, and finally, I'm gonna stop this and upload the next one in a bit. Ladies and gentlemen. In a bit. So those are the 4 examples that you need to know. Practice drawing them. If you can draw them and keep practice drawing them, and if you can draw them with your eyes closed, brilliant. Just make sure your eyes are open in the exam. But if you can do it very, very easily, you've got easy marks there.